Okay, great.
Let's see if it works for 5 minutes now.
All right, so I was talking to you about the fact that multi-cloud, we need modern APM and observability. And I'll demonstrate a hands-on application. We have set up a real live application running on AWS and Azure, and we can also have Q&A at the end. So very quickly, multi-cloud is here already. Many surveys point the fact that customers are already choosing multiple clouds, both on-prem and across public clouds. And it's a question of if you're not there already. And it's a question of, it's not a question of if, it's a question of how many. Is it 2 or 3, Azure, AWS, or GCP? So with that in mind, what are the good and the bad things? So the multi-cloud allows you to mitigate lock-in flexibility. You don't need to get stuck in with one vendor. They don't need to hold you hostage. You have better disaster recovery. You could share one microservice across multiple cloud providers, multiple availability zones. You have lower latency. You can cherry pick the services based on your needs. You don't need to settle for one particular cloud vendor solution. For example, if you like Microsoft Azure's AI capabilities, go for it. You don't need to settle with whatever you're stuck with. Now, the bad thing is obviously operational complexity, and monitoring is a pain because your complexity has just tripled or quadrupled. Monitoring one cloud itself is a pain. Monitoring multiple clouds just intensifies the effort involved in keeping tab of everything. So here's the application I'm going to show you. I'm moving quickly. The user accesses the browser. The browser reaches out to an on-premises Docker-based application. It's the front-end service, which in turn calls AWS. And it also calls Microsoft Azure. And you have a payment service, which is what I'll be focusing on because of the time constraints. And that will be calling an external payment gateway. So obviously in this demo, I can show you a whole lot of things. Many things could go wrong here. But I'll be showing you mainly problems on Azure. It could also be AWS, but in this case, I want to show you how to pinpoint the root cause. So here's the link to the demo. If you are in front of your mobile or desktop, go to this bit.ly link, e2evc-demo. I'll do that right now. And it will open up this e-commerce application that we have put together, which demonstrates. Now, this e-commerce application is running on multiple clouds right now. So I'm going to sign up as myself, and I'm going to submit. And I'm now logged into the e-commerce application. Like any other e-commerce application, you can add items to cart. You can view the cart. You can check out. You pay using a certain credit card. It gets submitted, and your payment went through successfully. Now, in this particular flow that I've shown you, we have actually touched many machines along the way, along on-premises, along AWS and Microsoft Azure. And it's gone to a payment gateway. Now, just to demonstrate slowness, what we have done is we have put in an intentional slowness around the MasterCard, this red button here. And you can log in yourself and try it for yourself. When I pay using MasterCard, I get a slowness. It's hanging. I'm not getting a reply back from the payment gateway. Now, this is obviously poor experience for customers. And the longer this continues, customers are going to flood your call center. Right? So I could not get a timely response from the payment gateway. What do I do as an IT ops, as a cloud ops? How do I keep tabs on it? So I'm going to switch into the demo. I'm on the home page right now of EG Innovations, EG Enterprise. And my first entry point is the service, the entire web store application as such. So right now it's showing green, but in a moment it's going to start showing in KPIs. It's going to start showing metrics that indicate that there is a slowness. So first things first, I just wanted to show you that I already have traffic coming in from Portugal, from UK, from Germany and India. So we have already captured the fact that there are people logging in from these countries. We have already captured the various URLs that were traversed during that shopping experience. So add to cart, billing details, and so forth. And right now, the user experience is showing a smiley face right now. But as we start to get a poor experience, it should start to change right now. I'll jump into the troubleshooting in a moment, but I also want to show you that when you look at a multi-cloud, you want the ability to look at cross connectivity like this. So my users log on to the web store application, and that is served by a front end microservice hosted on premise. And that is calling a bunch of services on AWS. And it's also calling Azure, as this icon suggests. And that in turn is calling the payment gateways of Visa and MasterCard. Now, what we have done in EG is we have automatically identified these transactions, and we have used the metadata coming in from these cloud services, and we have tagged them appropriately under the right buckets with no manual intervention. So for example, AWS would have the AWS availability zone and the region, and likewise for Azure. And those that do not have such tags, we club them under on-premise. You can even later give metadata to EG and club it accordingly. So if you look at this, pretty much we have arrived at the same logical architecture diagram that I showed you on the PowerPoint. We have pretty much arrived at it in real time in EG Enterprise. Now, my first click, my first visual right away is the fact that all the green ticks on AWS suggest that everything is fine on AWS. It's Azure that's the problem. Specifically, it's the payment service that's the problem. And if I click on it, I go right away into this alert box that says many slow transactions for payments, which is exactly what I showed you. And I can then start to diagnose this. So let me reload this for a second. I want to click on this and drill down into so my first click is really drilling down into the actual offending transactions. In which case, in this case, it's payments. So I'm going into a slice and dice analytics. This is totally automatically detected. My first click came here. My second click was another level of drilling down into a specific transaction, which took 20 seconds. While this loads, I want to show you the fact that you have all the necessary information here. The number of transactions, the average response time, and if there are SQL queries, you get the information there as well. At this point in time, my focus is on why it was slow, and it's very clear it's the MasterCard payment gateway. That was the slow offending culprit here. And that call took 20 seconds to load. And I can also drill down into my third, where I don't really need it. I'm getting the input that it is MasterCard. But if I want another level of execution analysis at the code level, I can do that. I know that my HTTP URL connection to MasterCard was pretty slow. It's 20 seconds. And eventually it timed out as well. So in 3 clicks, what I have demonstrated is we went from a visual representation of cross-cloud topology. My first click took me to the fact that the payment microservice is slow. It was apparent visual, but I clicked on it. I now look at the extent of the problem. It is pretty problematic. There are many slow transactions. We can also capture the business context here as to which particular e-commerce product was impacted. And you get a bunch of rich information, which will take time for me to go into. But I wanted to show you the fact that very quickly, another click took me to the MasterCard. I don't need to raise, or I don't need to get a war room here. All I need to do is raise a ticket against the vendor, in this case, the payment gateway, right? So coming back, what's very clear here is you need the right multi-cloud visualization to start with. You need auto discovery, which is what I showed you just now, with no manual intervention, because your developers could create a new dependency at 2 a.m. in the morning and you can't go there and hook it up manually. The APM should automatically detect it. If you only have an infra monitoring tool, it will not detect the connectivities that I'm showing you right now, because the infra monitoring tool will only show you a static view of the health of a particular component. Because you marry the two, APM and infrastructure monitoring, you get a very rich context here. You not only get the health of each component, you also get the cross connectivity and the invocations from on-premise to cloud. It has to be dynamic because, as I said, at 2 a.m. in the morning, when a new Docker container comes up, or when a new pod is spawned in your Kubernetes cluster, the tool has to automatically pick it up. You cannot go there and configure at 2 a.m. in the morning. Moreover, in container environments, containers come and go all the time. Static will not cut it. So legacy old tools will not cut it. We have designed it to be dynamic in this case. Intelligent thresholds, auto baselining, these are, I'm sure you're aware of it already. I also showed you the in-context alerts. I clicked on it and immediately got an alert, and that one click is probably enough for a normal help desk person to route the ticket immediately. That person need not be an expert. Intelligent color coding. So in this case, the fact that you don't need to wake up everybody else. It's the payments that's orange in color. That's impacting the front end layer. So don't wake up your front end Angular JS or React developers. They are not to blame here. The problem is also not the payment microservices. It's actually the third party, which I showed you just now. And easy triaging is exactly what I was telling you so far. So pinpoint very quickly, even with non-experts, in a very complicated multi-cloud environment, visual root cause identification, quickly go into and spot the problem right away. I want to quickly show you one or two dashboards and then I'll close the presentation. So you need the ability to see multi-cloud side by side. So for example, if I go into this multi-cloud health dashboard, which is again automatic, we create it as a one-click dashboard. When you have multiple clouds, will automatically pick it up because we have already clubbed it. You can see app health and infra health side by side. And when you project this on the TV screen, you're now bringing a cultural change because you're bringing in the infra sysadmins as well as the app development, DevOps, SRE kind of communities coming to a single TV and then a console and talking about, okay, how do we optimize the system? So in this case, it's very clear my on-premise URLs, my AWS URLs, and my Azure URLs. It's very clearly segregated. And the payments is the problem. as we already saw. But the key thing is, usually what happens is it's like I am fine, you're not fine kind of finger pointing. Doesn't this dashboard sort of kills that anti-pattern, because the infra health is absolutely fine. The cluster is up 100% on-prem, on Elastic Kubernetes service, on the Azure Kubernetes service, which is EKS and AKS respectively. They are up and running all. They are absolutely fine. The transaction response time is the problem. As you can see here, the spike to 20 seconds is the problem. That is because of the payments URL on Azure, right? So it could be that in a multi-cloud microservices architecture, your microservices team could deploy the same payments microservice on both AWS and Azure. And this helps you sort of triage very quickly. I'll quickly show you another multi-Kubernetes health, because if you're looking at a Kubernetes administrator, they usually are flying in the face of complexity. Pods come and go, containers come and go. There's no idea about an aggregated view. So what I'm showing you right now is AWS and Azure side by side. We have automatically determined which regions they come from. US East, in this case, this is on AKS. You know how many nodes are up and running, how many pods are up and running, CPU, memory, failed, pending, the overall pod status. And from there, it's another level of drill down into the containers. And from there, you can keep going to the host level. But the point being, you need the ability to automatically detect and give them on a single console. You cannot give our sysops communities on a very fragmented, siloed kind of tool sets. The complexity is high as it is. The monitoring tools cannot add more complexity to it. They need to cut the complexity even further. Something else I just want to finally show you, and then I'll stop, is you need also the ability, like I said, to bring in communities on a single platform, on a single console, and let them talk to each other. And what I'm showing you is an end-to-end observability dashboard where the application topology is based on your traversals of your navigation. On the left, you're seeing the cluster health and availability across AWS, EKS, and on-premise. It's not categorized like that, but next level of detail will reveal that. The overall Kubernetes summary is available here, and you can get the number of packets in egress and ingress. If there is any packet drops, that gives you the ability to go down that path. You also have the logs, because at the end of the day, observability is all about logs, metrics, traces, and events. And we have integrated everything into a one common out-of-the-box dashboard. So it gives you the logs down to the individual thing. So for example, if you look at these logs, I know that somebody tried to add an 8 GB memory card here, and an amount for about $999 failed because of payment. So I'm now elevating the IT ops team into a business oriented, business intelligent kind of team. Also, events are very important. So what events are happening? How many pods are running? Is the network available? Are there any failed containers, failed images? Are all my services running fine? So each of the microservices owners want to know if their own service is running fine. And you get them on the same page over here in this whole set of services. And from an application perspective, you get a trend of how many healthy, slow, error, and stalled transactions. So quickly talk about, yes, we saw the fact that you need multiple viewpoints from a monitoring perspective. The application owner wants to hold the cloud vendors honest. The IT operations wants to raise the right tickets to the right cloud vendor. Developers want to know which piece of code is running on which cloud platform, which is the problematic, irrespective of the cloud vendor and the framework. The support needs to route the right tickets, and DevOps need to deploy fast on multiple clouds. So how do you answer these questions? It's through multi-cloud monitoring. Ready? Here's a quick checklist I put for you. You need to unify multiple cloud vendors on a single console. It's not enough to put it on multiple. You can't swivel chair between multiple. You'll lose your mind. You need to track it side by side, like I showed you. You need intuitive topology visualizations, clear clubbing and segregation by the cloud provider microservice. I've not shown you the next level of detail where within the cloud, you could actually go into various services. So for example, I'm quickly show you AWS cloud. You need the ability to say, okay, how's my EC2 service health? How many instances do I have? How many are powered on, powered off? What size of EC2 instances do I have? Where are they? In this case, we have drawn a map to show that it's one is in the EU and one is in the US and so forth. So this level of detail will keep going deeper and deeper. But what I showed you was a very high level bird's eye view. You need the ability to see that cross cloud interactions. It's not enough to see one cloud at a time or one cloud watch and then another X-ray and another Azure insights on different consoles. That will just introduce a next level of complexity. You need to pinpoint the root cause. I showed you a third-party issue. It could be a code issue. It could be an infra issue. It could be the fact that there's not enough CPU getting allocated in your EC2 instance. It could be the fact that the EC2 is running pretty close to your cloud credits, the budget that you have. You need the ability to pinpoint the root cause, get the logs, metrics, traces all in one console. And very importantly, I want to raise this point. It's very difficult to prove to cloud vendors that it's them, not us, because typically that's how it is. The interaction is a little tough because they would immediately want to find out if it's the application, if it's you rather than them. So we need proof points. We need the right logs. We need the right traces. We need the right screenshots, like I showed you, to say that it is the sometimes it's the cloud vendor. So you need that proof points. I'll stop here and open up for any questions.
All right. Any questions here? No? Okay. Thanks, Arun, for your presentation, for your patience with us setting it up.
Thank you.
Want to add that yesterday we showed a lot of our digital workspace monitoring functionality, and today we showed quite a bit of our APM monitoring solution. I think there's one interesting point about EG is that this is all just one solution, right? So it's a modular solution. You only have one EG manager running in your environment, and you can just add modules. So you can start with digital workspace, you can start with APM, or start with just infrastructure monitoring, and just build out as you go. So when your company changes or when your business changes, you can just keep adding those modules and replacing it, and have it all in the same system. So thanks, everyone, and have a good lunch, I think.
Thank you. Thank you, everybody.